Hello everyone and welcome to today's webinar. Today we'll be talking about the practice of DevSecOps and how to help security teams come up to speed using best practices to take advantage of the cloud. My name is Joe Rahimzadeh. I am a Senior Solutions Specialist at Logicworks as well as an AWS Certified Solutions Architect. Just to let you all know, today will be roughly a 30-minute presentation, and if you'd like to get in touch and discuss any of these topics in further detail, my contact information will be displayed at the end of this presentation. So really quick about Logicworks, our focus as an organization is on designing, building, automating, and providing ongoing management for cloud infrastructure. We've been doing this for more than 20 years. We are an AWS Premier Partner as well as an audited MSP, and we hold competencies in healthcare, DevOps, and marketing and commerce. Our focus is on 100% customized infrastructure for our clients, so we have a lot of experience across a wide range of business verticals and needs. Our largest footprint is in the security and compliance domain, and so we specialize in HIPAA and NIST standards, PCI, SSAE 16, and SOC 2. We also take a very practical approach to using DevOps and automation to maximize the value of the AWS cloud, and we'll talk about that today. So here's the big question. Every day, enterprises call into Logicworks and ask, can our security teams keep up with the speed of the cloud? Can we actually improve the way we're doing security? How does security fit into the process of deploying and testing new systems? How do we ensure that there is central governance and visibility in a dynamic environment? Well, Amazon has actually developed the answer to that question, these questions, and we'll get to that in a few minutes. But first, it's important to try and understand the technology shift that's happening today. So here's an oversimplification, but this depicts the traditional role of security teams in the enterprise. They usually act as a gate. And what do I mean by that? This means that security comes in at the end of a process to test and audit new systems. In this model, security is really just a single step in the process, and it's one that you have to get past rather than work with. So these security folks are creating extensive documentation around policies and processes that must be continually updated, and in the end, they may or may not be implemented by the engineers who are actually building the systems. So this creates a disconnect between the folks whose job it is to ensure that the systems are secure, the security team, and the engineers who are actually implementing and operating them. So let's fast forward to today and take a look at how the cloud is changing the way we interact with our infrastructure systems. Today, AWS has become the major cloud player in the industry, and it's forcing enterprises to change the way they think about security. According to a recent study, the vast majority of enterprises, 81% in fact, are in the midst of DevOps adoption. We can share that with anyone who'd like to see the report. But what does it mean? It means that security teams simply can't spend weeks testing every new system. Change is just happening too fast. And so while this is a really exciting time to be building on the cloud, it's a worrying time as well for large organizations who are trying to figure out how to be more secure and more agile at the same time. So if you remember a few slides ago, we asked the question, can security move at the speed of the cloud? And Amazon's answer is yes, but more specifically, the answer is DevSecOps. So DevSecOps is a set of practices, processes, and technologies designed to bring security teams up to speed and leverage new ways to protect your cloud. Simply put, really, it's the goal. The goal is to make security faster and smarter and more well-aligned with DevOps teams. So today we'll be touching on a few topics to help us better understand what DevSecOps is and why it really matters to technical and business folks alike. Oftentimes, the greatest security risk we expose ourselves to is due to a lack of process which causes an engineer to miss a small detail. When we think about major security issues in business today, we typically imagine a massive data leakage or some mistake made by an engineer that's on a large scale. In fact, oftentimes it's really the minor details that present the greatest risk. The small oversights, they can open us up to major exploits, and so we'll talk a bit about that today. So as the world shifts its thinking to automation and infrastructure as code, the question becomes, how do we maintain compliance while becoming more agile? And today we'll talk about how automation can make you more compliant and reduce risks associated with storing, processing, transmitting sensitive data like credit card information and things like that. And lastly, we'll discuss the practicality of achieving security and compliance with automation as a safeguard, and how organizations should approach the idea and practice of DevSecOps. I'd also like to note that DevOps is a spectrum, and so it's really important for an organization to understand where they are on that spectrum so that they can take a practical approach to becoming more agile. At Logicworks, when we see an enterprise try and go from 0 to 100 miles per hour in automation, it can be more trouble than it's worth. And so this is a really great reason why you should have experts, either internal or external, that can help you identify the best way to implement DevOps and DevSecOps. So DevOps sounds like yet another buzzword, which in IT we're no strangers to. It sounds like another ambiguous and complicated term, but actually it's about leveraging the tools enterprises are already using. Tools like configuration management and AWS native tools for monitoring and deployment, and then taking all of that and building processes around the tools to make sure that you're following best practices throughout. So in a recent survey of American CISOs, Chief Information Security Officers by Information Week, the biggest concern wasn't access control or really even preventing data breaches. It was managing complexity and enforcing security policies. So it's no wonder why Gartner named config management as the #1 server protection priority recently, even above firewalls and intrusion detection systems. Most enterprises already use configuration management, but interestingly, it's never listed as a top tool. Firewalls usually actually steal that top spot. So configuration errors and mistakes have contributed to some of the biggest attacks in the last 5 years. For those of you who keep up with the news, in 2014, healthcare.gov was hacked because a single development server was not configured properly and actually used default credentials. Valve's multi-million-dollar game streaming service called Steam went down during a holiday sale because they deployed an incorrect caching configuration. These are not big and they're not complex errors. These are really small, easily overlooked mistakes that could have been avoided if only the right tooling and processes were in place to act as a guardrail for engineers so that they were prevented from making those mistakes in the first place. So here again, an oversimplification of a configuration error. Your initial system or instance shown on the left it's perfect, right? You have all the right packages. You have multi-factor authentication required on the instance, and the latest patches have been applied. But then something happens, an event, or someone makes a change, and if this process is not leveraging automation, DevSecOps, really, the manual nature of the change coupled with the likelihood of human error means you may be missing some critical item, like, for example, the latest version of SSL. It's not a difficult mistake to make, and in fact, it's pretty common in the world of manual work. So the problem is, when you're a retail company on AWS, the nature of your business likely means that you're changing your environment very, very frequently. The system is constantly adding and removing capacity, you're auto-scaling up and down, your team is making changes to configuration, and so on and so forth. You also have very strict and very prescriptive PCI regulations for safeguarding your systems, so configuration is even more important. The scenario depicted here is a pretty simple setup, but when you're thinking about achieving compliance at any real scale, it's really easy to understand that a small detail can get overlooked. So here in a multi-region deployment that is dynamically adding and removing resources to find a balance between cost and performance and availability, improper processes and a lack of automation around configuration can mean a critical misstep in the bootstrapping process, which, as all of you probably know, it's the most vulnerable time in an instance's lifecycle. So if we look at the diagram here, the instance in the web tier of the lower right region may not have all the necessary security policies attached to it. And to an individual who's looking to exploit your system and capture your data, this is an enticing entrance point into your environment if they can find it. So here we're going to talk about some principles of DevSecOps, and really, first, it involves making security teams part of the DevOps process. This way they can make a positive impact rather than slowing things down as outsiders. It involves acknowledging that security is possible at speed and scale, and the old way of thinking and old processes aren't going to work in the cloud. And it's really crucial to change the mindset internally to adopt this new way of thinking, because your business and your security, frankly, depend on it. Secondly, DevOps is all about building guardrails rather than setting up gates. We'll talk about that a few times throughout this presentation. In other words, you want to task your security teams with preventing errors by creating templates that have built-in security configurations so developers can't make mistakes in the first place. And by getting involved earlier in the cycle, security doesn't have to be a gate at the end of the project that you need to get past because they are in every step along the way. We'll talk about manual work, and this cannot be overstated. Manual work introduces tremendous risk to the enterprise, especially at scale. So a few things with that. Human memory, right? It's limited, and the bigger the infrastructure, the easier it is to forget to close some security loophole when launching a new environment. Something like forgetting to remember to require MFA on some instance. So engineers are really smart people, but they're people, and they make mistakes. Manual work is really time-consuming. It's much more efficient use of time for an engineer to maintain some automation script that ensures security rather than the time it takes to hunt down, patch, and upgrade individual components of your instances. So patches, we just mentioned that. They're very core to security, and they must be done on a regular basis. But when you're looking at hundreds or even thousands of instances, no human can be 100% certain that the patch is in place across all of these systems without automation. Break your own software. What do I mean by this? So much like Netflix has developed the Simian Army tools to do destructive testing on their infrastructure, you should apply that same logic to setting up teams of security professionals that are constantly trying to gain access to your environment. This is really, it's a major step up compared to just passively monitoring. So the first of these principles is really a way of thinking. It's sort of a cultural shift. But once you decide that this is the way forward, and truly this is the way forward, you need to implement some pretty key technologies to get started. So we'll discuss each of these in some detail, but at a high level, here are the main components in implementing DevSecOps in your organization. Infrastructure templates. These should be built and maintained using CloudFormation. Maintaining these rather than individual components of your environment is a far more efficient use of engineering time, as we mentioned before, and it will eliminate really costly errors caused by manual updates. Config management using something like Puppet or Chef will give you much more granular control over your resources and should be used in tandem with infrastructure templates that you've created through CloudFormation. And then enforcer scripts. These should be written and maintained to enforce and continually check in on security policies across your AWS systems. The overall theme here is that you want to treat your cloud like a piece of software. You want to build something that is modular, versioned, and frequently changed without sacrificing security and compliance. So in the next few slides, we'll talk about 5 steps to help you implement DevSecOps within your organization. This is the first part of our journey to building guardrails that will ensure your engineers and developers don't make mistakes. So the first step towards building guardrails for your development team is to decide which security policies should actually be universal across your enterprise or across your team, and then baking those into CloudFormation templates. The templates are constantly available to DevOps teams to pull from a central repo, which we'll talk about later, so that the DevOps team are using these templates with the correct security controls and can't make a mistake. So a common mistake, for example, might be forgetting to register a DNS name on one server out of 30, or one server out of 100, or one server out of 1,000. With these templates, you don't need to remember to register a DNS name because it's already built into the template. So for those of you who are not familiar with CloudFormation, let me take a step back. It's a native AWS tool that allows you to lay the basic building blocks of an environment, think networks and naming conventions and things like that, laying it all out in a predictable and orderly way. So CloudFormation kind of sets the stage for a configuration management tool to further increase the granular management of your security processes. So next, your security team should embed security configurations in your Puppet or Chef scripts. At Logicworks, we have a central Puppet module that has the basic policies that our clients will use for most of their own environments. The types of things you would embed are items like requiring multi-factor authentication on the Bastion host or the jump box, enabling CloudTrail to track API calls across the system, really a crucial tool for compliance when it comes time to an audit, and we'll talk about that later, and configuring things like CloudWatch. Then we go ahead and customize it for each client, taking into account special packages and deployment pipelines. It's really these per environment modules that are changed most often, so our security teams are constantly improving these scripts. And if you're implementing this in-house, your security teams should also be improving these scripts on a regular basis. So here we see sort of the insurance policy you get when using automation to establish guardrails. The fact that there is a central module means that you can patch your entire system in minutes and know with 100% certainty that every single environment meets the new configuration when it checks back into Puppet. This really combats the limitation on human memory that we see when patching systems manually and especially at scale. So, little combination of the previous two steps. Some enterprises use CloudFormation templates. Some enterprises use configuration management tools. The key really is to use both together to make sure that you are taking a holistic approach to managing your systems in a way that really guarantees security policies are adhered to, and it's done in an automated way. So while none of these tasks are really too daunting or complicated, at scale you really need to make sure that the tools you're using give you enough fine-grained control to avoid missing some simple little step that could cost you in the end. So using enforcer scripts to continually check in on your systems is pretty crucial. This is a collection of Puppet or Chef scripts to check for things that your organization determines are necessary to achieve security and compliance, and they're common across all of your environments. So you can be sure through using configuration management and CloudFormation that a system is up to date with the right security policies when it's launched. But let's think, what happens if an engineer mistakenly changes something? So for example, someone with access to the system could accidentally disable CloudTrail, which, as I mentioned earlier, is really crucial for PCI auditing purposes. An enforcer script will constantly scan that environment to see if CloudTrail is enabled, but more than just telling you that it's not on, it will take it a step further, and without human intervention, it will turn CloudTrail back on. And in the case of working with an MSP like Logicworks, it would alert our network operations center, who would then research the alert and notify your security team. So enforcer scripts really make sure that your system is always up to date, and it provides that continued insurance and peace of mind so that that perfect system that you built at first stays perfect. So from there, we put everything into a GitHub repo, and that's co-managed between us and our clients, or if it's internal, between your security team and your DevOps team. It seems pretty simple, but actually it's very powerful. It means we can effectively outlaw one-off changes and require that if you want to make a change to any system, you can't just go in and change the instance in the CLI. So if you were to make a change, the process would look something like going into GitHub, checking out a branch of your Puppet manifest, making the change, then submitting that change to either a senior DevOps or security team member, and then that team member would approve it. So this means you have a record of every change ever made on your system and a way to roll back changes that don't work. So we'll talk about it later, but having been in the compliance world for some time, you can be sure that auditors love this. When this is implemented and frankly followed, you will very rarely need to access the actual environment. All the work is done with temporary assumed roles. So in essence, we're managing our entire security process like a piece of software, ensuring that it's modular and it's versioned and it's frequently changed. So when this is implemented correctly, DevOps engineers can actually make a security improvement and get a diff file that shows them the exact change between the original and the updated script. So a key part to iterative improvement is destructive testing, as I mentioned earlier. This is where part of your newly trained security team actually becomes capable of continually breaking into your own systems, or at least trying to. The team's usually called a red team, and they operate independently of your regular security and DevOps teams to penetrate your IT defenses. The security team could also use tools like Netflix's Simian Army Suite to see how security policies are maintained when a failure actually happens and things come back up. So whether you outsource this or develop these skills in-house, destructive testing highlights the importance of security professionals also being coders and systems engineers, and if they are, the benefit to your organization will be tremendous. So to sum it all up, sum up those 5 steps, the culmination of following the processes in steps 1 through 5 really have led us from the traditional security process where security operates as a gate with no clearly defined role throughout the entire process. It leads us to this, a very cyclical DevSecOps process where security teams have a very clearly defined role in every step of the process. So anytime your developers need to spin up a new AWS environment, this is your new improved process for doing it quickly and securely. First, the systems engineer would retrieve the standard operating environment, aka the combination of CloudFormation and configuration management that's appropriate for the environment, which has, by the way, already been vetted by the security team. Then you'd modify those templates to meet specific requirements and submit those back to code reviewers or the security team, whomever on your team is responsible for that. The security team would then tell the systems engineer if there are any security flaws that must be addressed prior to launching. But if you have the green light, you would then deploy the environment through the deployment pipeline that security already helped create. Then ongoing iterative improvements are pushed out to the system over time as enforcer scripts improve. This really is the model for an agile secure operation. So again, using tools like CloudFormation along with configuration management tools like Puppet or Chef, you can stop relying on forgetful humans to implement things the right way and ensure that your systems stay up to date. You'll always know the state of your system's configuration at any point in time. You'll have everything documented and you can roll back when necessary. You can correct configuration drift, which will open you up to vulnerabilities and can paralyze an organization that's trying to achieve security and compliance at scale. You can rest easy knowing that every system is patched and it didn't take you hours and hours of engineering time to make that happen. Really quick plug for Logicworks here. Our blog is really great and contains a lot of unbiased technical content. You can check that out at gatheringclouds.com or by going to Logicworks' website. So in the next few minutes, we'll take a look at some examples. Some of these will show you how the elements described previously, when you combine them correctly, will actually make you more secure in a more broad sense of the word. Then others will relate specifically to PCI Compliance, which I'm sure many of you will find particularly interesting. So here, the first example is something that is so simple that it's often overlooked. So at Logicworks, when we take over management of an existing client's AWS environment, we do an extensive gap analysis to uncover issues that need fixing. When we do the initial security gap analysis of our client's environment, we often see something that looks like this, right? A list of security groups, all with the default name, launch group number. So imagine you task a systems engineer to open an instance to the internet, and the engineer mistakenly opens launch wizard 1 instead of launch wizard 10. It's a really simple mistake, just caused by not striking the 0 key, but suddenly sensitive information is exposed to the internet. And in the world of PCI compliance, hefty fines could be lurking right around the corner. So CloudFormation effectively prevents this from ever happening. You would simply tell it what to name resources following your standard naming conventions, and then you maintain the template rather than each individual instance. And even more than that, no engineer would ever be able to edit a security group from the console or CLI. Instead, you edit the CloudFormation template and submit it for review, as we discussed earlier, which would then allow the security team to cache the error. But thanks to versioning, even if the error went through, you'd be able to roll back the changes in seconds. And that would be a great way to limit risk. So not to beat a dead horse here, but this is a key example for compliance. If your organization has to adhere to PCI compliance regulations, a crucial tool to leverage is AWS's CloudTrail. It has to be enabled on every instance in order to track API calls across the environment to know exactly which person accessed which system and made what change. So in the DevSecOps process, you always launch new environments from templates with Enable CloudTrail built in, but even if it's not configured or if an engineer mistakenly turns it off, the enforcer script would come along afterwards and turn it back on. The enforcer script is actually running constantly, so again, that same process would happen. If someone turned it off, it would be turned back on by the script. So let's say you've built most of your environment in Northern Virginia, and suddenly someone launches a big instance or group of big instances in Singapore. Actually, this is a fairly common attack, and someone who gets access to your environment launches a big instance, and they do things like Bitcoin mining or generally just hide their activities. And if they're any good, they're going to turn CloudTrail off while they're at it. Chances are it's probably not an attack and one of your engineers just made a mistake. But those new instances, if they were launched manually, probably aren't following your security standards, and will also be costing you real dollars as long as it's running. In either case, the enforcer is constantly checking for this and alerts your team or our NOC to take action on it. So when you're following DevSecOps best practices, you're already checking off a lot of the boxes that help you through a compliance audit. So when the auditor comes through and reviews your systems and processes, they'll ask you for a number of things. When you have this process implemented, it's very easy for you to turn over your CloudFormation templates, your GitHub documentation, and any other items, and that will greatly reduce your audit burden. Quick note about audits, since Logicworks goes through them fairly regularly. Audits are a really time-consuming task and require a lot of engineering resources to provide information to that auditor. So when you have a lot of this automated and you have all these best practices built into your templates and your configuration management, handing that over means that your team can get back to work faster rather than sitting in a conference room answering questions for an auditor. So with that, we'll take a look at some examples of PCI compliance using DevSecOps. So here's a really simple example, but this is an S3 bucket policy that shows that you're denying any unencrypted uploads into the bucket. It would also require that your applications use encrypted storage for sensitive data. It would ensure without human intervention that you're meeting PCI standards. An auditor would take one look at this and know with confidence that for at least this part, you are adhering to PCI standards. So let's touch on containers a bit. Really rapidly evolving technology that has garnered lots of attention from the enterprise. When you're trying to understand how to use containers and achieve compliance at the same time, some very serious research must be conducted. I highly recommend speaking to AWS and to third parties to better understand how to use this technology and how to remain compliant. So the question is, can you achieve compliance while using containers? And we've seen that the answer is absolutely yes when it's architected and monitored properly. So for compliance and security reasons, it's often critical that a container's logs are shipped to a central log repo. And access to that container is monitored in real time. Logicworks has partnered with another AWS premier partner, AlertLogic. They're our partner of choice for satisfying both intrusion detection and log review, log management compliance requirements. So when you look at a system like this, AlertLogic log monitoring and intrusion detection would be installed on the EC2 instances in the ECS autoscaling clusters. So this means that the logs are organized by instance and not by the container, task, or cluster. The containers would then ship the logs to the central log repository on the instance, and then the instance pushes it to CloudWatch logs. IDS would integrate directly with AlertLogic's security operations team, where they can notify your team to take action on a particularly suspicious bit of activity, or interface with Logicworks' Network Operations Center to take action on your behalf. So to answer the question, yes, compliance is available and possible on a containerized system. So achieving PCI compliance is a very expensive task and gobbles up finances by way of having to purchase security tools and software and internal staff time and effort, not mentioned in the number here, but not being in compliance can also come with a very hefty price tag. So automation really streamlines your process to ensure that you're doing more with less human intervention, and it actually reduces your risk of security breaches that lead to those big fines that I mentioned. So achieving compliance in an agile environment requires us to change how we think about how DevOps and how security work together. So this represents really an outdated view on achieving security and compliance in an agile workflow. It used to be that the faster you move, the worse off your governance and visibility is. And it's really still a common thought among many of the groups that I talk to on a daily basis. It requires us to educate those technical and business leaders within an organization using a lot of the concepts we discussed here today to show them that security can move at the speed of the cloud. And to do that, we have to automate. Automation really is the glue that binds agility with security and compliance. We no longer have to become less secure when we move fast, but instead just the opposite can happen. By building security resources and capabilities for your engineering teams to consume like they would any other resource, you can move very quickly and very securely. So whether this happens in the planning phase of moving to the cloud or after your organization is already there, with DevSecOps, you're introducing a centralized, scalable, cloud-ready approach to enterprise security and compliance. With that, thank you all very much. Again, if you have any questions or comments or would like to discuss these points further, please feel free to contact me, Joseph@logicworks.net. I would love to hear from you. Again, thanks for joining.